So good morning, everyone. Now we'll start today's lesson. Already we have started transport modulation system. Over there, we are going to discuss about how to convert an analog signal into digital one. The whole process. The process those are involved in analog to digital data conversion. Those are mainly sampling. Okay, sampling processes. Then we have to quantize the signal. Then the coding. So this whole process, by taking one signal example, we'll discuss here to make you understand. For better understanding, just you take one signal here. So already in the last class, just we have started. So that's why today I am going to start from the beginning. 1 second. Now see, this is the signal here, xt. Okay, this is the signal here, xt. We have taken for the example. Now this is the graph +4, -4 here. So this is the maximum signal amplitude is here -4 +4. Okay, so this is the graph here. This is the graph. The black bar, this is -4, -3, -2, -1, 0. Here +1, +2, +3, +4. Okay. Now the first thing is that you have to sample the signal after certain interval, that is sampling instant. So sampling instant TS, it may be 2 milliseconds, 3 milliseconds, 4, 6 as per our requirement depending upon the signal frequency. Okay, we'll take the sampling frequency as well as the sampling instant. So this is your x-axis. Okay, this is 0, so this is your x-axis. That means in this x-axis we are plotting time, along this is the amplitude. Okay, now listen everyone carefully. So the first sampling instant is this, second sampling instant is this, third is this, fourth, fifth, this is sixth, in this way, seventh and eighth, in this way, that is fourth. Here we have considered only the positive side, so someone can take a negative as well, no problem at all. So this is the first sampling instant. From this to this is TS, from this to this is the time gap is also again sampling instant, that is TS. This is also TS. Okay, so between these two sampling point, the time gap is TS, as we know. From this to this, the time gap is TS. From this to this time gap is TS. So the first sample value here, see, this is the first sample value. This is the sample point is this. Second sample point is this. Third, fourth, fifth, sixth. In this way, it moves on. Okay. तो दिखाई दे रहा है? Is this visible? I think this is clear. So you will get the clear view over there. So now this point, okay, this sample value, this is plus one, this is plus two, okay. So what should be the this value? Okay, you have to estimate here. Okay, as it is graph. So if we having the graph paper, so from there we can find out the.
सर आपका वॉइस ब्रेक हो रहा है
Okay.
सर आपका वॉइस ब्रेक हो रहा है और
Now once check it. Hello, improved little
यस
bit.
ठीक है
Acha, chalo. So you have to find out the actual value here. Okay, now see, goes down the sample value. This is I have written here 1.4. Okay, so the sample value, that is x nts. You can write here it is as x of nts. So this is 1.4 actual value, because this is 1, this is 5, the middle is something like that, so it could be 1.4. Okay, now move to this point, the second sample value. So this is 3, this is 4, it's very close to 4. So you have to find out this value. Okay, and I am taking this 3.7. Okay, so sample value, the second sample value is 3.7. Okay, so this is I estimating. We are here. So this is your 3.7. Now this point. Okay, so these are very close. Okay, so see what is the actual value here? 3.6. Okay, just below to that. So that's why very close. So that's the 3.6. Okay, now this value. Okay, so this value. Okay, this sample value. Okay, so anyone from your side, can we assume what should be the value here? This is C, this is 2, this is 3. So it could be 2.6, something like that. What I have taken, 2.5 we have taken it is. So you can take it 2.6 also. Okay, this is 2.5 middle one. So it will be better if you choose it 2.5. Okay, say 2.6, little bit upper. So you can correct it 2.6. Okay, you make this point 2.6. Okay, now come to the next sample value. This point. Okay, so this point देखो ये very close to +1, so it could be 0.9. Okay, so 0.9. Now see this value. Okay, so this point is, see here, very close to -2, isn't it? This line is -2. Okay, so this is 1 minus 1.9. So this is very close to -2, so that's why it could be minus 1.9. But these lines you don't have right now. Okay, you will add these lines, but पहले ये line नहीं होगा, ठीक है? So that's why you have to find out actual sample value from the signal. Okay, so this is minus 1.9. Now this value. Okay, so this is point minus 3. Okay, and this is minus 4. So it would be minus 3.3. So in this way, whatever be the sample point, you have to find out all sample values. That is x of n. Okay. So after getting the actual one, now you have to quantize. Okay. You have to quantize. Okay. So to find out quantization level, listen everyone, please listen everyone. So XNTS means क्या हो गया तुम्हारा? ये discrete time signal मिल गया, ठीक है? But this amplitude may be any value. This signal up to this, it could be minus infinity to plus infinity. It could be minus 50 to plus 50. The signal strength should be minus 30 to plus 30. Whatever be the signal amplitude, peak to peak amplitude, you have to quantize by means of some particular levels. Okay. So whatever be the peak to peak amplitude, that amplitude that signal strength must be quantized by means of particular, okay, by few constant number of levels. That is called quantization level. Okay, here we are going to use 8 number of quantization level. 8 number of quantization level, and it is always 2 to the power something, power of 2 hoga. So 8 means 2 to the power 3. If we take 4 number of quantization level, so it should be 2 to the power 2. So 2 to the power 2, that is 4, 2 to the power 3, that is 8, 2 to the power 4, that is 16, 2 to the power 5, that is 32. So here we are going to use 8 number of quantization level. Okay, so 2 का power कितना होगा? 3 होगा. So 2 to the power 3. That means, what does mean by this 3? What does it mean by this number 3? Okay, so this 3 basically it representing the number of bits. Everyone please listen carefully. This 3 basically representing the number of bits required to sample each and every, okay, sample value, required to code each and every sample value. That means this point 1.4 point or 3.7, whatever you are getting the sample point, this amplitude must be represented by means of 3 bits. Okay, so 0 0 0 maybe 0 1 0 0 1 1, okay, 1 1 1, so by means of 3 bits. Okay, so in general you can write 2 to the power n. Okay, in general you can write 2 to the power n is equal to L. So what I'm telling you is that the number of quantization level, if it is L, it should be 2 to the power of n. Okay, where n is equal to what I am telling you, number of bits. Number of bits. Okay, number of bits required to code. Okay, per sample. So number of bits per sample. Okay, number of bits per sample, and this is your n. Okay, what is L? L is the number of quantization level. Okay, what is L? Sometimes it may be written as Q, sometimes it may be written as L. So don't worry about that. You can follow anyone. So number of, क्या मैंने बोला? Number of quantization level. ठीक है? Quantization number of quantization level. Okay, so there is a relation L is equal to 2 to the power n. So here I have taken L is equal to 8. So naturally it should be 2 power 3. That is n is equal to here how much? 3. L is how much? L is 8. Up to this clear? तो क्या क्या टर्म मिला? नंबर ऑफ क्वांटाइजेशन लेवल. लिसन एवरीवन. अच्छा, नंबर ऑफ बीट. What is the relation between number of bit required to sample or required to code each and every sample? That is n, and 2 to the power n is nothing but the number of quantization level required to quantize the signal. Acha. Now the spacing between any two quantization level, how to find out? You have to place quantization level. These 8 number of quantization level you have to place. Okay, so what should be the gap between two consecutive quantization level? Are you listening to me, everyone? Is it clear?
Yes, sir.
Okay, so now we are going to find out the step size S. Okay, so what is I am telling you that step size? Just a minute. Okay, ये पिछले दिन का बोतल आज भी दे दीजिए. So step size, how to find out step size? Okay, so step size, I am writing S. Sometimes it may be written as del also. Okay. Some book, if you find in some book, basically in Sanjay Sharma, it may be step size del. Okay, and S in Counseling sound. So you can choose any one. So space S is step size. So means the gap between any two consecutive quantization level. So that is nothing but, listen carefully everyone, V peak to peak. That means the signal what you have taken for sampling. So that signal is having some peak to peak voltage, nothing more than that. So peak to peak voltage is there, VPP. उसके साथ क्या होगा? Divided by total number of quantization level, L. Okay, so sometimes it is written as L, sometimes it is written as, okay, Q. So basically thing is that peak to peak voltage by L. So in our case, what is peak to peak voltage? Tell me anyone. In our case, what is peak to peak voltage? The signal what we have taken here, I have already told you, -4 से +4 तक. ठीक है, it start from -4 to +4. So what is the peak to peak voltage here? बोलो, what is peak to peak voltage? Minus Vm is -4 and plus Vm is +4. So what is peak to peak voltage? Anyone? बोलो, -4 से +4 तक. So what could be the peak to peak voltage? सुनाई दे रहा है ना? So what could be the peak to peak voltage? Okay, if you don't know, I can give you the answer. That is 8 volt. So peak to peak voltage is 8 volt because -4 से +4 तक. Simple. I would expect that I will get the answer from your side. So it's 8 volt divided by, what is the total number of quantization level? What we've taken here, total number of quantization level? Prince? Prince? Hello?
Yes, sir.
What I have taken here, the number of quantization level. Do you follow me? Here we are assuming how many number of quantization level, that I am asking.
Sir, 2 sir, -4 to 4 ना sir.
हाँ, -4 to 4, तो पीक टू पीक वोल्टेज कितना होगा?
8, sir.
8.
Sir 4 sir होगा. 8 divided by 2.
अरे कौन बोला तुमको? पीक टू पीक वोल्टेज कितना होगा? 8 होगा ना? हैं? और टोटल नंबर ऑफ
Yes,
क्वांटाइजेशन लेवल कितना बोला? L इक्वल टू मैंने क्या बोला? 2 to the power 3 बोला ना?
3. Yes
3
sir.
क्या
Yes.
है? ये फॉर्मूला था ना, L इक्वल टू 2 to the power n, where
Bits,
n is the total
sir,
number
bits.
of quantization level. Correct? नाउ हम लोग क्या फाइंड आउट कर स्टेप साइज, मतलब ये हम लोग क्वांटाइजेशन लेवल इस तरफ प्लेस करेंगे, ठीक है। तो ये जो बिटवीन जो गैप है ये स्टेप साइज एस है। एनी टू क्वांटाइजेशन लेवल का अंतर क्या है, एस। तो एस का वैल्यू हम कैसे फाइंड आउट करेंगे, दैट आई एम गोइंग टू डिस्कस। उसका फॉर्मूला है वी पीक टू पीक, मींस तुम्हारा पॉजिटिव पीक कितना है, नेगेटिव पीक कितना है, सो दैट विल गिव यू द टोटल पीक टू पीक वोल्टेज। हियर हाउ मच पीक टू पीक वोल्टेज, बोलो ना,
8 sir.
हाउ मच
8
हियर इज द पीक टू पीक वोल्टेज। -4 से +4 तक मैंने बोल दिया, तो पीक टू पीक कितना होगा,
8 sir.
8 sir
8
वीरेंद्र
8
पीक टू पीक कितना होगा,
8 sir
अरे बोलो,
8
-4
sir
से +4,
plus
तो पीक टू
sir,
पीक क्या होगा,
8
8
sir
होगा।
plus yes sir.
And we have taken the total number of quantization level, how much, 8.
Sir.
Okay, so क्या हो गया, 1 volt और 1 यूनिट। तो अंतर क्या होगा, एनी टू, देखो तुम लोग नहीं बोलोगे तो हम पढ़ा के चल जाएंगे, that will be difficult. I'm asking you whether you are getting or not, you have to ask me the question, otherwise if I ask you the question
sir.
whether it is understandable or not, you have to give the answer.
Hello sir.
So
Hello
I'm
sir.
trying to make you understand, follow me. So this is 1 volt, okay.
Hello.
So
Hello,
1 volt
sir.
कैसे हम लोग फाइंड आउट किया है, द फॉर्मूला इज स्टेप साइज का क्या है, v पीक टू पीक डिवाइडेड बाय एल। ओके, पीक टू पीक का मतलब क्या है, प्लस जो मैक्सिमम
Hello
वोल्टेज है
sir.
माइनस
Hello.
तरफ जो मैक्सिमम वोल्टेज है वो तुमको ऐड करना पड़ेगा, सो दैट्स इट विल गिव यू
Hello sir.
पीक टू पीक। कारण यहाँ पे -4 से स्टार्ट से +4 तक वोल्टेज का एम्पलीट्यूड है, सो 8 वोल्ट हो गया एंड डिवाइडेड बाय टोटल नंबर ऑफ क्वांटाइजेशन लेवल, सो 1 यूनिट। ओके, so step size is equal to 1 unit or s or del, whatever you can say, this is 1 unit. So ये between two any quantization level गैप कितना होगा, 1 यूनिट होगा। ओके, 1 यूनिट का अंतर होगा, ठीक है। तो चलो देखो यहाँ पे, तो 1 यूनिट का अंतर है, देखो ये तुम्हारा 0 है, ये 1 है, ठीक है। तो पहला वाला इस बीच में होगा, फर्स्ट क्वांटाइजेशन लेवल यहां से शुरू होगा, ठीक है। तो -4 शुरू से शुरू करो, -4 यानी -3 है, ओके। सो -3.5 में फर्स्ट क्वांटाइजेशन लेवल को हम लोग प्लेस किया है, देखो फर्स्ट क्वांटाइजेशन लेवल को। तो मैंने क्या बोला, 1 यूनिट गैप होगा, तो दूसरा कहां में होगा, -2.5 में होगा। गैप कितना है, 1 यूनिट हो गया, करेक्ट। तीसरा जो थर्ड कहां होगा, ये -2.5 है, तो ये क्या होगा, -1.5, गैप कितना हो गया, 1 यूनिट, ठीक है। यहाँ पे देखो -0.5 में होगा, देन ओनली गैप इज 1 यूनिट। ये -0.5, सो डेफिनेटली 0.5 में होगा, तो गैप कितना है, 1 यूनिट। फिर 1.5 इधर है, सो सिक्स नंबर जो क्वांटाइजेशन लेवल है वो 1.5 में है, 6 की कहां 7 कहां है, 2.75 में होगा, और लास्ट जो है 8th नंबर, if you count from 1 2 3 4 5 6 7 8, so it would be at 3.5. So these are the quantization level, point of the quantization level. First one -3.5, the second one -2.5, third one is at -1.5. Okay, in this way it moves up to 3.5, and the last quantization level placed at +3.5 volt. The first one is at -3.5 volt. Okay, now see each and every place the gap between any two consecutive quantization level, the gap is 1 unit, correct, gap is 1 unit. फिर देखो ये 0 पोजीशन में जो है और 7th पोजीशन में जो है, देयर इज ऑल्सो 1 यूनिट गैप। व्हाई, बिकॉज देखो ये 3.5 है, ये 4 है, तो ये गैप कितना है, 0.5 है, ठीक है। और इधर देखो ये -4 ये -0.5 है, तो दिस लेंथ कितना है 0.5 है। सो ये 0.5 एंड ये 0.5, so if you fold them, so it will give you 1 unit. So throughout the process, the gap between any two quantization level is 1 unit. Okay, so primarily what do you get, the all the quantization levels, okay, all the all the sample values. So you have find out pehle sample values, these are the sample values, okay. Then we have placed all the quantization level that you require. Here we have used 8 number of quantization level and we got the step size. Accordingly, we have placed all 8 quantization levels and we found their corresponding voltage levels. Okay, the first one is at -3.5 and the last one, that's 8th number of quantization level, is at 3.5 positions. Accordingly, the middle quantization levels are placed by maintaining 1 unit gap between two. Okay, so now you have to approximate. Okay, what you have the sample values, we got these sample values. Now you have to approximate by means of quantization values, nearest quantization level.
Hello, sir.
Okay,
Hello, sir.
so you have to find out now नियरेस्ट क्वांटाइजेशन लेवल, जितने सारे तुम्हारा सैंपल वैल्यूज है एक एक करके फाइंड आउट करना है उसका नियरेस्ट क्वांटाइजेशन लेवल कौन है, एक एक करके। तो देखो पहला वाला क्या है 1.4 है, तो 1.4 जो पॉइंट है क्वांटाइज सैंपल पॉइंट है उसका नियरेस्ट क्वांटाइजेशन लेवल कौन होगा, 1.5 है, वन पास में ऊपर साइड में 1.5 है देखो और नीचे में 0.5 है, तो कौन सा क्वांटाइजेशन लेवल उसका नियरेस्ट होगा, नियरेस्ट नेबरेस्ट। ओके, तो बोलो यहाँ 1.5 है इधर 0.5 है, तो कौन सा वैल्यू तुम्हारा, कौन सा क्वांटाइजेशन लेवल तुम चूज करोगे, ये 1.5 और 0.5 कौन सा, ये तुम्हारा फर्स्ट सैंपल वैल्यू। नियरेस्ट कौन 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 होगा, दैट मीन्स एरर कम कौन होगा। ये देखो 1.4 है ये 1.5 है, तो क्लोजली कौन है 1.5 is very closest, so that's why we'll take 1.5 quantization level. So that's why I have written here nearest quantization level 1.4 का nearest quantization level कौन है 1.5 है। बस any quantization value, any sample value may have two
Hello, sir.
quantization levels,
My
upper
voice
and
is
lower,
clear, sir.
but you have to choose which one is very closer. Okay, so first one is for your 1.5. Now 3.7 देखो ये 3.7 है, this is the sample value, तो उसके पास क्या है देखो 3.5 very close, very closer, so we have taken 3.5. okay, so now देखो ये वाला है 2.5 है, ठीक है, और मैंने बोला था 2.6, तो उसका क्लोज क्या है 2.5 है, 2.5 है। नाउ देखो ये 0.9 वाला है 0.9, ठीक है, ये सैंपल वैल्यू 0.9 है, तो उसका देखो 0.5 में एक क्वांटाइजेशन लेवल है, ठीक है, और 1.5 में है, तो व्हिच वन यू विल चूज, डेफिनेटली 0.5 वाला, सो 0.5। ओके, सिमिलरली यहाँ पे कौन है देखो -1.9, सैंपल वैल्यू क्या है -1.9, तो -1.9, तो वो -1.5 ही क्लोज होगा क्योंकि -2.5 बहुत दूर है, so -1.5 very closest, so that's why we have taken the nearest quantization level, that is -1.5। 3.3 है लास्ट में, अंत में 3.3 है ये सैंपल वैल्यू, उसका क्लोजेस्ट क्वांटाइजेशन लेवल कौन होगा, आइदर -3.5 होगा ना -2.5 होगा, which one होगा -3.5 होगा, तो -3.5 हम लोग ले चुके हैं। तो इन दैट वे यू आर गेटिंग नियरेस्ट क्वांटाइजेशन लेवल्स। नाउ देखो इतने सारे जो क्वांटाइजेशन लेवल हम लोग ले चुके थे, from starting from minus 0.3.5 से plus 3.5 तो we have to give some code number. कोड नंबर देना पड़ेगा. तो पहला वाला क्या है? 0 है. सेकंड वाला 1 2 3 4 5 6 7. In that way we have given all the code numbers. Okay, so each and every sample वैल्यूज का कोड है. -3.5 का कोडिंग कर दिया 0, -2.5 पोजीशन में जो क्वांटाइजेशन लेवल था उसके लिए 1. इन दैट वे 3.5 में जो क्वांटाइजेशन लेवल है उसका कोड नंबर 7 मिल गया. तो देखो, सो दैट्स व्हाई यू हैव टू राइट नाउ कोड नंबर्स. ठीक है, ये कोड नंबर. टुडे आई विल शेयर दिस पीडीएफ नोट. सो -1.5 देखो, -1.5 सॉरी ये क्या है, +1.5. +1.5 का कोड नंबर कितना है? +1.5 का कोड नंबर कितना है? देखो बोलो, ये क्या है? 5 है. तो 5 कर दिया. ठीक है. तो दूसरा क्या है? 3.5. 3.5 क्वांटाइजेशन लेवल का क्या है? देखो सबसे ऊंचाई में है. 3.5 का क्या है? 7. तो हम लोग लिख दिया 7. फिर से 3.75 है तो इसलिए 7 हो गया. 2.5 का कितना है? देखो 2.5 का 6 है तो 2.5 का 6 हो गया. 0.5 का क्वांटाइजेशन लेवल का कोड कितना है? 4. सो 4. -1.5 क्वांटाइजेशन लेवल का कोड कितना है? -1.5 कोड है 2. तो 2. ठीक है. लास्ट में क्या था? -3.5. -3.5 का कोड कितना है? 0 है. ठीक है. तो इन दैट वे वी गॉट all the code for quantization levels. This is 5, this is 7, 7, फिर 6, फिर 4, फिर 2, फिर 0. Now, as we have taken 8 number of quantization level, so each and every sample value must be coded with 3-bit binary number because 2 to the power 3 is equal to 8. So that's why 5 कितना होगा? 101 using 3 bits. 7 कितना होगा? 111. ये 7 क्या होगा? 111. 6 क्या होगा? 110. 4 क्या होगा? 100. एवरीबॉडी वी नो. 2 क्या होगा? 010. एंड 0 क्या होगा? 000. सो देखो, ये है तुम्हारा अल्टीमेटली बाइनरी रिप्रेजेंटेशन ऑफ द कोड नंबर्स. सो मैंने क्या बोला था? sampling the total procedure, sampling, quantization, ultimately the coding, so code number, so binary representation, so that I have shown you. So this is the process. If I give you any one signal, okay, so you have to do it by your own. and exam में ये जो system है ये 100% आ सकता है, बहुत chance है आने की. And the whole process is called pulse code modulation system. The whole process what I have described in now, the process from sampling to ultimately binary representation of the code number. So the whole process basically is called pulse code modulation system. Okay, so we had one analog signal, we have sample using sampling process, then we have quantized by using some sort of quantization levels, and how the quantization level depends upon the total number of bits required to code each and every sample value. So I told the relation. Then the step size, what could be the gap between any two quantization level and how to measure the step size, that I also described you. And then we find out the nearest quantization level. Then we got the code numbers for each individual quantization level. Then we got the binary representation. So up to this, if you have any doubt, anyone, if you got any doubt regarding this whole process, so you can throw your question to me over me. So I am giving you 30 seconds or 40 seconds. If you have any doubt, because this is most important, and I have seen most of the cases this question come. You are writing, I am not listening your voice. So that may be problem. Someone writing,
हेलो सर।
हाँ हाँ सुनाई दे रहा है, हाँ. Someone has written.
सर
बोलो.
आवाज नहीं आ रहा था सर। सर ऊपर में जो सैम्पलिंग वहां पे बताइएगा, सैम्पलिंग से हम लोग स्टेप जो निकाले वो कैसे निकाले। सर पिक टू पिक वोल्टेज का जो फॉर्मूला था उससे पहले।
नेटवर्क बहुत प्रॉब्लम है. वॉइस तुम्हारा मैं ठीक ठाक से नहीं सुन रहा हूँ, थोड़ा थोड़ा.
सर आपका ही
सर
नेटवर्क इशू है।
आपका नेटवर्क इशू है, बहुत प्रॉब्लम हो रहा है, बहुत कट कट के आवाज आ रहा है।
नेटवर्क प्रॉब्लम है. तुम जो बोल रहे थे मैं कुछ कुछ सुना, कुछ up to this. That's why I'm taking much time. Okay. तुम बोलोगे तो और हम टाइम ले लेंगे, कोई बात नहीं, क्योंकि लेकिन ये पूरा प्रोसेस हम बोल रहे हैं डिजिटल कम्युनिकेशन का, ये